Unit 7, Features of Functions. Section 1 is going to cover the coordinate plane basics. The objective for this lesson is that you should be able to tell the story of a function. So let's start with some vocabulary that we're going to be using throughout this lesson and the unit. First, the coordinate plane. That is what we see off to the right here in your notes. This coordinate plane is where we're going to be doing all of our graphing for this unit and for all future units that require graphing. It's important to be able to correctly identify the different quadrants in the coordinate plane. And this is the way you should be able to identify the coordinates in this coordinate plane. The quadrants for the coordinate plane go like this. Quadrant number 1 is in the top right. Quadrant number 2, top left. Quadrant number 3, bottom left. And quadrant number 4 is in the bottom right. So when it comes to identifying the location of certain points that we're going to be graphing with respect to the quadrants, this is the order in which you should be able to identify those quadrants. Next, we need to identify the two axes that separate the four quadrants of the coordinate plane. The x-axis is the axis that is horizontal on the coordinate plane. So this, again, is the x-axis, the axis that is horizontal on the coordinate plane. The y-axis is the axis that is vertical on the coordinate plane. The origin is the location where the x and the y-axis intersect. So the point of intersection is the origin. And finally, ordered pairs, which sometimes people call the coordinates, are the names of the locations of these points that we're going to graph on the coordinate plane. So let's move on to the first exercise, which goes over ordered pairs and or coordinates. Now, it's important to remember when it comes to coordinates, the understanding that coordinates is made up of two parts. These two parts of a set of coordinates has both an x value and a y value, separated by a comma. Now, these values tell you where this particular point, this location, is with respect to the x and the y axis. So let's start with point A on the grid. Now you notice that point A is located in the first quadrant. And in that first quadrant, we also have that point where it's located with respect to the x-axis. With respect to the x-axis, right, that point is located at a value of 2. So the first half of our coordinate for A is 2. It also has a location with respect to the y-axis. So looking at where it is with respect to the y, we see that it also has a value of 2. So that's going to be our y component for our coordinates for point A. Okay, so point A has coordinates or an ordered pair of 2, 2. Moving on to point B. Again, writing the coordinates, we're going to first look at where B is located. It's located in the second quadrant. And with respect to the x-axis, we see that it is located at -4. So I'm going to write -4 in for the x-coordinate. With respect to the y-axis, this point B, look across, is located at a y value of 2. All right, so the coordinates for point B is -4, 2. So let me give you some time here to see if you can figure out the coordinates for both C, D, and E. Well, how did you do? All right, so for C, you should have -2, -3 for the coordinates. For D, 4, -3. And for point E, 1, -4. All right, let's move on to example 2, where we're going to be plotting these points. So we're given the ordered pairs, and we need to find their exact locations on the coordinate plane. All right, so let's start with point S, which is located at 2, 5. So again, to plot these points, we are going to first look at the x component for the coordinate plane. And this one has an x-coordinate of 2. So starting at the origin, we're going to move over to 2 on the x-axis. All right. So now without actually making a mark, we're going to now look at the y component for that ordered pair. And the y component is at 5. So that means from this point, we're going to move up 5. All right. So x component of 2, y component of 5. That brings us to this location on the coordinate plane. So this is point S. Let's do point A. So starting at the origin, we now need to move to -3 along the x-axis. So we're going to move left to -3. The y component is a +4, so we're going to move up 4. So from there, we're going to go ahead and make our mark, and that's going to be point A. Let's do one more here, N. So starting at the origin, the x component is -5, so I got to go to the left to -5. And the y component is -6, so this time I need to go down. So I find myself in the third quadrant, right here at -5, -6, and that is point N. All right, so let's see what you can do with the remaining points for this example. All right, check your graphing with the ones here you see on the screen. Again, if you find yourself having a little trouble with the graphing, these components, make sure you come see me for some extra help. Now moving on to the next questions is, what do you think of when you hear the word graph? Well, again, depending on the way that the word is used, right? It could be used as a verb, or it has to graph the coordinates, or it can also be used as a noun, which means create the graph for the situation. All right. In any event, we need to make sure that we are able to correctly identify the independent variable versus the dependent variable. The independent variable are usually the values that are represented along the x-axis of a graph. And the values are, as it says, independent of anything else. It does not rely on any other values for its particular value. On the other hand, the dependent variable, which are values represented along the y-axis of a graph, its value depends on the value of the independent variable. All right, so we're going to be using this to help us to interpret graphs. And when it comes to interpreting graphs, it's about trying to draw relationships between the independent and the dependent variables. So for exercise 3, we want to determine the independent and dependent variables in each scenario. Part A says Bob was working at a printing company. He is making t-shirts for a high school volleyball team. The press he runs can imprint 3 t-shirts per minute with the school mascot. So in this scenario, the number of t-shirts that Bob can print depends on how much time he has. Therefore, the number of t-shirts is the dependent variable, while the time is the independent variable. On her way to work each morning, Sophia purchases a small coffee for $4.25 from the coffee shop. So the dependent variable in this situation is how much money she spends. And that value is dependent on how much coffee she buys. So the number of cups of coffee or the amount of coffee is the independent variable. Let me give you some time here to read through example number 5. Let's see if you can identify the independent and dependent variables in this situation. All right, so in this scenario with the plane, the independent variable is time, while the dependent variable is how fast the plane is flying. And the reason why speed is the dependent variable is because depending on where you are during the trip, the speed of the plane changes. So again, the speed of the plane depends on what time you are in your trip. Now let's see if you can figure out which of the 4 graphs best matches the situation with the airplane. So of the 4 graphs, you should have chosen the one in the bottom left. Let's see why that one best matches the situation. So the first thing we were told was that the plane sat on the runway for 20 minutes. So that means it was just sitting there, not going anywhere. As you can see, there's the first section of our graph that I highlighted where the speed is 0, but it's just sitting there for 20 minutes. No speed change. After sitting on the runway for 20 minutes, the plane finally took off and flew at about 600 miles per hour for about 2 hours. And here's that section of the graph where the plane took off, and then for 2 hours it was going at 600 miles per hour. Then it reduced its speed to about 300 miles per hour and circled Midway Airport for about 15 minutes. Here we see the reducing of the speed from 600 down to 300 and just hanging around Midway Airport for about 15 minutes. And then after landing, the plane taxied to the gate and stopped. That would be represented by this section of the graph. All right, that's it for today. Go on to the 7-1 homework.